happens. Nothing really fanciful happens that we don't know about. But let's ask about the type of variable A. Now remember, only values in Python has the notion of data type. Variables themselves essentially are multi-type container. They are allowed to store any data type, including composite data types and structured data types. So when we ask Python, what is the type of a variable? Actually, it's a shortcut way of saying what is the type of the value contained in the variable. Let me be clear again. It is a container, right? Labeled A in this case, and it contains something. That something has a data type, whether integer, floating point, string, or Boolean. Yeah, okay. It is actually that something inside, the item inside's data type that we are inquiring. So oftentimes you may see from downloaded Google codes or something that says, what is the type of a variable name like this, type of A? When actually we are asking, what's the value of A? Python go and look at it and then tell me the data type of that value, the thing that's contained inside the container. And not surprisingly, it is int. Yeah. So suppose now I say 5 point. Notice that it is also the quantity 5. However, the point here, the 5 point, is a manifest type literal in the sense that it physically tells us this 5 is to be stored as a floating point, not an integer. So if we ask, what is the value contained in the container called A2? It's float. What is the type of 5 point? It is float. Remember, it is the type of the data value, not the variable name. So it is totally legitimate to ask, what is the type of this value string, including manifest type literals. So if we say type of 5, however, int, of course, you guessed it, right? Yeah, it is because it should be congruent to the type that is manifested by this literal that we have typed into Python. So let's just finish up our understanding. What's the type of B? What's the type of C, which is bool, bool. Now, this type here that you see, this bool here that you see, is a type. All right, it is not a string. Just remember that. Huh? And for example, if we say the type of C, is it equal to the string Boolean? No, not really, because the type of Boolean, this object here, because type of C is a Boolean, type of B is a float. When the type function returns this float, this Boolean, this int, it is another value, which again has a type. So we might even, let's just finish up. So it's a string, right? We might even ask this string here, this guy called string here, returned by the function type, right? What is the type? Because it's a value. So yeah, we can ask Python. We can say, what is the type of that thing that was returned by type D? All right. So it is basically a type that describes the data type of some data value. So it's very consistent, right? And of course, the type of the type of the type of D is type, because it is just a type that describes the type of type that describes the type of D. Okay, I know I'm getting you confused, but I'm absolutely clear because Python is absolutely clear. It is not confused. All right, so typically there is no need for us to ask type of type of type of type and so on. There's no need. But definitely there are a lot of opportunities in constructing program and debugging that we want to inquire about the value stored in the container, because it's not clear what data type it belongs. Like we see a 5, is it integer or actually a floating point that happens to be 5.0000, right? So we like to do that. And we can, of course, construct more examples with manifest type literals. More importantly, however, we like to convert sometimes. For example, the string 987, maybe because it was typed in by user, and the function that captures it returns us a string because it is a string. It could have been, I stay at block 987, or my phone number is 987654332. So if it's a string, how can we like maybe convert it into an integer or a floating point? That's type conversion. So we don't change the meaning of the value, but we want to change the data type of the value. All right, so that's what it means by type conversion. To do that, there are 4 supporting functions for from Python to convert anything to anything if it actually makes sense. For example, it doesn't make sense to convert hello to integer or float. Then you will get an error, type conversion error, type error. But if it makes sense, all right, that we are trying to convert string 987 into integer, that seems to make sense because we are expecting 987 integer or 987.0 float. Then yes, actually we can proceed by just float of the string or int of the string and so on. So we can do that. Okay, so that's quite easy to understand because the name of the type itself will force whatever data type value that we pass into that into the same type as the function name. So that's very convenient. And let's try to do that. So I'm just going to copy and paste over. All right, convert float, Boolean, string, int into each of them. So at first, A was an integer. We convert to float, Boolean, and string. And then we print it out. All right, and then we convert float into int because our B was a floating point number. Does it make sense to convert into integer? Sure, kind of like truncating the floating point. Does it make sense to convert into Boolean? Well, let's see. Does it make sense to convert to string? Yeah, of course. Just put a double quote around it. Seems to make sense. So we'll do that and print out the outcomes. We convert Boolean to integer, float, and string and see the outcome. And finally, we convert string back to integer, float, and Boolean and see what happens. So basically, we are performing all-to-all conversion. And of course, we have carefully chosen the content of, especially the string is the major offender. I've just picked integer, very nice, docile content. But if I've done hello there, we can try it out and see later on, then kind of all hell breaks loose, right? We'll see what happens. Now, let's convert. So the first line here came from converting integer into float, which is okay. 5 converting to 5.0. 5 convert to Boolean is a true because it's not a 0. 5 convert to a string is just a string 5. That's great. Nice, right? How about B? B originally was a floating point. Let's convert to integer. That's just throwing the decimal place away. Convert to Boolean. Most floating point numbers will convert to true because you need to be exactly 0 to get a false, right? So convert to string, just wrap the quotation marks around, so that's pretty safe. So string tends to be more generous. It tends to be able to be converted into, but it tends not to be converted from string to anything else because depends on what is inside. Yeah. So for a string, let's just finish up the Boolean first. If C has a Boolean false, converting to integer, we see that it's exactly 0. Right, converting to, did I convert to Boolean? No, I should be converting it to, let's see. I should be converting into float, right? Let's do that. Okay, and then convert to string. And finally, I should do a float here and then float. All right, so let me just clear the Boolean, the console and run it again. So what was our C? Our C was a false to begin with. Integer 0, convert to float 0.0. And if you convert 0.0 back to Boolean, you should get a false. A 0.1, however, will get you a true. Anything that's not 0.0. So a false converted to string should look like a false with a capital F, and that's what we get. Now a string. For the string to contain a proper integer representation, or floating point representation for that matter, that's fine. You can convert to string and float without any problem. But if you have a dot, that's okay. All right, dot 0, convert to string. Well, we have a problem because the integer was expecting something that is integer. So it's not so tolerant because you are asking for integer conversion. Now, Python could have made the integer smarter or more tolerant by just thinking that, oh, it's actually a float, but I can just ignore the decimal place and take whatever is digits up front, right? But this int here is pretty stringent. And there are probably good reasons to be so too, because in case you are accidentally converting something that you really don't want to do, to make sense of as an integer, then int should give you an error rather than quietly converting into something that is nonsensical and then continuing on. All right. So in this case, a .0 would do fine with a float, but not an int. But anything that goes into int can do with a float, right? So we can get good result. That's why I've very carefully chosen it to be a decent string. Yeah. Now, and then of course this string here converting to Boolean is a lucky thing because it is convertible into integer, and this integer isn't a 0. That's why we don't get a false, and hence we get a true. Okay, so far so good. Now, suppose I mask out the conversion into integer. We just want to see the float. So if we run this, of course, we will just see the float. But more importantly, if we put 0.0, this time round, earlier on, int was giving us problem. Now float can take it. However, if you have something that is misbehaving, like double decimal place, Python could have made the float more tolerant and say, okay, I can only understand up to here, so the number is 987.0. I just ignore whatever else I don't understand. So Python could have made float very tolerant, very generous, very forgiving, but no, just like int, it is very strict, and again for good reasons, because we meant it to be some sort of I don't know, log information, encrypted key information, whatnot. And little did we intend for anyone to convert it into floating point. But if you go ahead and just truncate the number and you end up getting 987.0 and you convert back to a string, you will lose the fidelity. You don't get back the original information. So perhaps for all these careful considerations, the float behavior is rather strict here, and we just have to be aware and not try to go through it. I would say that if you write your program correctly, you shouldn't have to think about hacking this to get around this stringent float behavior, right? Because it doesn't make sense to really want to convert original information 987.0.1 into 987.0. That doesn't quite make sense anyway. Okay, good. Let's just round up our discussion with a nice running of the full program rather than having an error there. Okay, now let's flip back to the original slide that we have. And basically that's our discussion very briefly and superficially touching on type conversion and the 4 basic scalar types that Python supports.